Hey, what's up everybody? This tutorial is going to cover the matched pairs T interval. So I'm going to run through an example and apply the four-step process to it. All right, so here's the situation. Police trainees were seated in a darkened room facing a projector screen. 10 different license plates were projected on the screen, one at a time for 5 seconds each, separated by 15-second intervals. After the last 15-second interval, the lights were turned on and the police trainees were asked to write down as many of the 10 license plate numbers as possible in any order at all. All right, so then a random sample of 15 trainees who took this test were then given a week-long memory training course. They were then retested. The results are shown in the next table, so I'll show you that in a sec. So let's estimate with 95% confidence the true average improvement of correctly identified license plates by trainees who took the memory course. All right, so we're going to be calculating a confidence interval in this problem. So here's the data. So we have 15 police trainees. This first column A is the number of plates correctly identified after the training. And then B is the number of plates correctly identified before that memory training course. So for this first trainee, they identified six before training and then 6 after training. So really there was no improvement for that first police trainee. So I'm going to just put a little 0 here, which will tell me that there was no change. Police trainee 2 started with 5 correctly identified, and then after the training course bumped up to 8. So that's a change of 3. So that was pretty good. So this trainee really did improve. For police trainee 3, no change, 6 and 6. Police trainee 4 is 7 and 5 for a difference of 2. So that improvement score there was 2. So what I'm doing is I'm calculating the differences. So what I'm going to do is I'm going to call this the D list. So the D list is the difference list. It's just the 2 lists subtracted. So this is what's called paired data. It's paired because each data set or each data value comes from the same source. So in this case, each police trainee is providing 2 different data sets. So it makes sense to do this subtraction, to do this, do these differences because each data value comes from the same person. All right, so I'm going to continue doing this D list. I'm going to make it a little easier and just do it on my calculator. So I'm going to go to my calculator here, and I'm going to look at my data. So I already have this in L1 and L2. So a quick way of getting the differences is just go to L3, go up so that it's highlighted, hit enter, and then we're just going to subtract L1 and L2. Right, you can see that I get those same values, so 0, 3, 0, 2. Okay, if I scroll down, I can see one trainee had a difference of 5, so that was a really big improvement. I do have a negative value, so a negative value would mean that the person actually did worse after the training course. There's not very many negatives. It looks like there's 2 of those. Okay, so what we're going to do now that we have basically our 2 data sets merged into one is I'm going to go and calculate the mean and standard deviation of this difference list, of this D list. So I'm going to go to one var stats, and I'm going to make sure that I'm doing L3 for my list. So I'm going to go down to calculate, and the numbers I'm going to use here is that first one, X bar. I'm going to call this D bar though, since it's differences, it's D bar, so 1.533. And then I'm going to use the sample standard deviation, S sub X. I'm going to call it S sub D though, since it's differences, and that's about 2.2. Notice that N value is 15. So I'll come back to the calculator in a minute, but what I'm going to do is now go back and write down that information. So the D bar value was the 1.533. S sub D, so the sample standard deviation of the differences, was 2.20. N was 15. All right. So now what I can do that I have that started is I'm going to start my 4-step process. So step 1 I am going to define my parameter of interest. Well, my parameter of interest is mu sub d. So it would be the expected difference, the expected amount of improvement. So I'm going to define this as the true mean improvement score so if the entire population of trainees took the course. And obviously, if I wanted this to improve the officer's ability to remember license plates, I would want mu sub d to be positive. But what I'm going to be doing as I'm doing this interval is I'm trying to estimate what mu sub d is. All right, so then I can move to step 2. I can do my conditions. So notice that so the first one is the random condition. I did take a random sample of those 15 trainees, so that will meet that first condition. So we do have a random sample. Notice we don't have 2 samples, we just have 1 sample, and then a pair of data for each sample, but we just have 1 sample and it was random. The next one is that you need your number of differences, or basically you need your D-bar sampling distribution to be normal. So one way to do that is just to make sure that you have over 30 observations. In this case, we only have 15, so that one's not going to be met. The second way to do it is to look to see would the population of differences be normal. Well, we don't really have a way of checking that, but another way we can do is we can use our data and just look at how is the sample distributed, and that can give us then some clues on what the population would be. So I'm going to go back to my calculator and I'm going to make a box plot of that D list. So I'm going to go to, again, second y equals plot 1. I'm going to make sure that my modified box plot is selected, which it is. I'm going to go to L3 for my X list. And then I'm going to do zoom 9. And I'm going to look at that box plot. So I can see, so what I'm looking for in the box plot is I'm looking for rough symmetry. It doesn't need to be perfectly symmetric, but I really don't want a heavy skew. And I also don't want to see any outliers. So here I do have a pretty symmetric box plot, and I don't have any outliers. So if I hit the trace button, I can take a look at the 5-number summary, because I'm going to make this on my paper in a minute. So that would be enough to show that the sampling distribution is normal. So I'm just going to quickly make that box plot on my paper here. So give it a quick scale. Right, so anytime I check one of these calculator graphs, I also want to draw it. So the minimum was 3, Q1 was at 0, median was at 2, Q3 was at 3, and my max difference was 5. So then I'll connect my box plot. Okay, so I drew it. I want to also interpret it, so I'll say the box plot of differences shows rough symmetry and no outliers. Okay, I also need my independence condition to be met. So remember that my sample needs to be no more than 10% of the population. Sample is 15, so if I multiplied that by 10, it would bring it up to 150. It's probably safe to assume that you would have that many trainees if you had kind of a large enough area. So let's write that. So it is reasonable to conclude sample is no more than 10% of the population. Okay, so that's step 2, and then to round that out, I'm going to say the conditions for a paired t-interval for mu sub d are met. All right, so I'm going to run you through now how to actually calculate this paired t-interval. So it kind of follows our similar confidence interval format. So it's going to be our point estimate, which in this case is going to be d bar, plus or minus our critical value of t times the standard error, which in this case is going to be s sub d over the square root of n. So basically we're just applying a one sample procedure to this d list. All right, so what we need next is we need to calculate this critical t value. So the critical t value comes from inverse t on my calculator function. I'm doing a 95% confidence interval, so for inverse t I put in the tail probability of that confidence level, so it's 0.25. And then I also need to put in the degrees of freedom as my second argument. Well, that's just n minus 1, so that's 14. So if I put that into my calculator, I get a t value of 2.145. So that's going to go into my formula, or my equation here. So it's going to be, so d bar is 1.533 plus or minus 2.145 times the standard deviation of the d list over root 15. So if I put the whole margin of error into my calculator, it ends up being 1.218. So my interval then, if I do my subtraction and my addition, my interval ranges from 0.315 to 2.751. So notice that this interval does estimate, it includes all positive numbers. So we do have a pretty good idea that this memory training course will improve police trainees' ability to correctly identify license plates. All right, so then once we have our interval now, we can interpret it. So I'll say I am 95% confident the interval 0.315 to 2.751 captures the true mean improvement score for trainees who took the memory course. All right, so that is the 4-step process. Let me also just run you quickly through the calculator function that will help out a little bit with step 3. So I'm going to just go back to my calculator here. I'm going to go to stat tests. So again, what I'm doing here is I'm doing a t interval with my difference list. So I'm really just doing a one sample procedure. So I'm going to go and select this t interval function. And because I already did one var stats, it has all my stats in here already. So I'm just going to go down to calculate, hit enter, and it'll give me that same interval I calculated using the formula. All right, so again, that's your 4-step process for your paired t interval for mu sub d. Thanks for watching.